Hello, welcome to Collin and Andrew Ding's AP Physics video.
Today, we will be discussing the physics of hitting a crossbar with a football from 35 yards out.
We hope you enjoy our video. From here going forward, we'll do a voiceover for the rest of the video. Thank you. This yellow metal pole that stretches across the bottom, splitting between the two poles, is called the crossbar. This is what we were trying to hit from 35 yards out.
The crossbar stands 10 feet off the ground and has a width of 18 feet and 6 inches.
We then found the circumference of the crossbar, and then we took 1/4 of the circumference, knowing that the ball can't hit 1/4 of the pole because of the angle of where it is thrown. The circumference of the pole where we could have hit was 23.55 inches.
The football is 11.4375 inches long, and its circumference is 21.25 inches in width.
This shape allows for the football to be spiraled, which reduces air resistance. The spiral happens when the ball spins off of the index finger. Air resistance, also called drag, is the forces that are in opposition to the relative motion of an object through the air.
The benefit of throwing a football in a spiral is that it allows for greater accuracy because the flight is more predictable. Holding a constant orientation means that the shape of the ball is always consistent, so the air resistance is also consistent.
We will now show you the actual videos of me throwing the football and hitting the crossbar. We will then go into the physics of the throwing motion.
Yep.
Standing 45 yards away from the crossbar, we were finally able to hit the football. We initially started at 55 yards away from the crossbar, but due to my lack of arm strength, I was not able to reach it.
Using the slow motion camera, we were able to figure out there was one rotation for every 1/10 of a second. Like we previously stated, these rotations help the ball travel more accurately.
Also using the slow motion camera, we were able to calculate the miles per hour of my arm as the ball left my hand. The ball was released at 33.4 miles per hour.
We found the speed by dividing the total distance traveled by the total time. We converted yards to miles and seconds to hours.
We found out that 45 yards equaled 0.0256 miles in 2.76 seconds, which was the time the ball was in the air for, equaled 0.0007666 hours. We then took the miles and divided it by hours, and this gave us 33.4 miles per hour. I released the football with an arm angle of 68 degrees. This allowed for the football to travel through the air and hit the pole.
Once Collin released the football, it became a projectile going along a parabola. There are two components of velocity affecting the ball, horizontal and vertical velocity, and they are vectors.
We will now show you a video where I was unable to hit the crossbar because I have a lack of arm strength and I'm a bad person.
Yep. Collin's throw was not successful because the ball left his hands at a speed of 33.3 miles per hour, 0.1 less than the original 33.4 miles per hour. 24 seconds late.
Yeah! Bob! Well, it looks like I have dinner, so I think this concludes our video. Thanks everyone for watching.
Thank you.
See you guys. Shout out Austin.
Austin.